Yes, all right. So I'm here today to tell you all about HTMX and to push back against complexity. You see the link in the lower left there where I have slides from all the talks that I give, and so you'll find my HTMX slides there as well. And I've already introduced myself a bit. So I'm trying to compress what is normally a longer talk into a much smaller amount of time. And so all these slides with a blue bird in the corner means that I need to skip past it quickly. And so you can grab the slides later and review this material. But here, it's just some terminology that's useful to know when you're working with HTMX. And really the main thing to know here is that we're after creating endpoints that return HTML instead of JSON. And you'll see coming up why that's a useful thing. You'll also see why what we commonly refer to as REST today is not really REST according to the definition from Roy Fielding, who coined the term. And so JSON-based APIs that we often create today, there's not necessarily anything wrong with them, but technically they're not REST APIs. And we're going to see how to implement real REST APIs that work with HTMX. And so that's really the main point of HTMX is that you can implement endpoints that return snippets of HTML that are exactly what you need to insert into the page at any given point. And so the HTMX library is free and open source, and it's been around for quite a while now and has a few corporate sponsors. One thing that you'll notice about HTMX compared with most other tech stacks is that it allows you to choose any programming language and framework you want for implementing those endpoints. And they refer to that as hypermedia on whatever you'd like, or HOWL for short. But there are certainly some tech stacks that are better than others. And so you want to pick one that makes it really easy for you to create new endpoints with any of the HTTP verbs and to specify type checking that should be performed on the data that you're passing into a request and what's coming out in the response. You want it to be easy to get data coming in on the request in all the common ways, whether it be an HTTP header, a path parameter, a query parameter, a request body. And then on the other side, you want it to be easy to create HTTP responses that can include headers and bodies that might contain just plain text or HTML and not JSON. You also want to pick a tech stack that has tooling that supports all of these things, really fast server startup. So it's no good if you're going to make a change to the code for your endpoints and you have a build process that's going to take 30 seconds or more. You want to have automatic server restart so that you can save changes to your endpoint source code in any language that you want to implement them in, and it can just automatically and quickly restart the server for you. You want to have good HTML templating support because if the endpoints are returning HTML, you don't want to have a complex API that you need to use for generating the HTML. And one example of one that I think is pretty good is JSX that you may be familiar with from work that you've done in React. And it turns out that there are server frameworks that support using JSX there as a way of generating the HTML. Of course, there's many other ways to generate HTML, and those might be fine as well. And then last, you'd like to have syntax highlighting in the code editor that you're using so that even though you've embedded generation of HTML into your code, that it's still able to give you some syntax highlighting of that. So with that out of the way, you've got to choose a tech stack, and I want to show some demos, so I have to pick one. So I'm going to go with TypeScript and Bun and the Hano framework. Of course, there are many other good tech stacks that you could pick. A lot of people like to use HTMX with Go and a framework called Temple. Then if you go with Python, you could use Flask or Django. And then there's the Astro framework in the JavaScript community that is also very good. But let's just quickly walk through how you could set up a project if you're using the tech stack that I'm choosing here with Bun and Hano. And so I won't go through all this in detail, but basically you need to install Bun and you need to initialize a Bun project. You need to tell it that you're using Hano in that project. There's a little configuration that you have to do for TypeScript so that it understands how Hano is using JSX, and rename a couple of files and then start it running. And it's going to listen on port 3000 by default. And here we have our first real code example. And this, I think, really demonstrates the flow of an HTMX app and shows how simple it can be. And so in the upper left, we've got our basic HTML. So I'm pulling in some CSS, and that CSS file is down in the lower left, I'm sorry. And I'm just doing some basic things. I'm picking a font and I'm styling a button. And you see the button there that says Get Bun Version. So you see the styling that was applied to that. And then in the body, I have a button and I have a div. And here's where the HTMX magic starts to come into play. So HTMX just gives you new attributes that you can add to HTML elements to make it do special things. And in this case, what I'm saying is that if the user clicks that button, I want to send an HTTP GET request to the endpoint slash version. And that's going to return something, text or HTML. And when that comes back, where do I want to put it? Well, that's what the HX target specifies. It says, I want to find an element with an ID of version and place that response there. So right now that div with an ID of version is just empty, but it'll get filled in when you click that button. So going over to the upper right, here's where I'm setting up my server using Hano, and it's really doing two things. First, it's serving static content out of the public directory. And that's where I have my index.html file and my styles CSS file. So I can serve those. And then when I get that request to slash version, that's going to return just text that has the lowercase letter v concatenated to the version of bun that I'm actually running on the server. And so you see in the little screenshot in the middle bottom there that the version I was running when I tested this was 1.1.30. So this, I think, is a really nice flow. I can implement that endpoint using any stack I want. Doesn't have to be JavaScript. And all I have to do is specify some attributes on HTML elements to say, what happens when the user interacts with this? In this case, I send a GET request to slash version, and where does the response go? Now, there's a bit more that you can do here, but this is just a very basic example. So as we saw, I'm using the Hano framework, and the tables you see on this slide are just summarizing some things that you might want to do with Hano. And so I encourage you, if you want to try HTMX with a different tech stack, take the time to create these tables for yourself, because these are things that you're going to do over and over again as you build out the endpoints. So you need to be able to get data out of a request in many ways. It could come from a request header, a path parameter, a query parameter, or it could come from the body in many ways as just text or form data or JSON. So get all of that straight for the framework that you're using. And then on the right table, it's summarizing how you can build a response. You need to send data back as a header or maybe a status code or something in the body that can be text or could be JSON or HTML. Maybe you want to return a 404 error or redirect to another URL. So yeah, create these tables for the framework you're using to make implementing your endpoints go much faster. Now, there's a bunch of pros and cons to using HTMX, and I don't have time to go over these in a lot of detail, but I'll just hit the highlights here. So there's some shortcomings in HTML that only certain elements can trigger HTTP requests, but HTMX fixes that because you can trigger them from any element. Startup time is going to be faster with HTMX. Locality of behavior means that I can look at a little snippet of code and it's very clear everything that's happening. And we already saw an example of that. If I go back to this slide and look at that button element, it's very clear what's happening with that button based on those HTMX attributes that were added. And so they refer to that as locality of behavior. Enables you to use any tech stack you want on the server side. It encourages full stack development because as you're implementing endpoints, because they're returning HTML, you kind of have to be a front-end developer too as you're implementing the back end. And it enables you to complete full stories on your project because you can work on both the front and the back end. Eliminates JSON as an intermediate format, and so you don't have to spend the time to serialize data into JSON and then on the browser deserialize it. You just go straight to HTML and skip a step. You don't need to version your APIs. This one's interesting, and this is the case because you just create endpoints that are specific for your app, not ones that are going to be used by multiple web apps. And if you need to share some code between them, it probably has to do with how you're fetching data or how you're updating data. And you can always write functions that do those things that you would share between apps. But the HTML generation part and the actual endpoints can be specific to each web app, and so you don't need to version those. Simplify state management because most of the state is going to be maintained on the server. And I'll talk later about how you can also store some state on the client using a different library. Simplifies the client-side code because really you're not going to be writing much JavaScript code there. There's JavaScript running in the client, but it's mostly coming from the HTMX library itself and triggered by those attributes that you're adding. Now, there are some cons as well. Maybe the biggest one is that this is just a new way of thinking about developing a web application. And so it's going to take time to get used to thinking in that way and implementing code like that. And it's certainly not appropriate for all apps. If you have an app where you need to update the UI every time the user moves or drags the mouse, that's probably going to be too slow. And so Google Maps is an example of that. And there's certainly games that wouldn't be good to implement with HTMX, but there sure are a lot of web apps that do fit with HTMX. And the last con here is that it might be a little difficult to find code examples that use HTMX with your chosen tech stack. With other frameworks that always use the same tech stack, all the examples you find will be with that stack. But with HTMX, suppose that you're a fan of using Go. Well, many code examples will be in Python or in JavaScript. And so you'll have to mentally translate those to the tech stack that you chose. But over time, you can expect more and more examples to exist in a lot of different tech stacks. I'm going to skip over this history slide because I really want to get to showing more examples before our time is over here. And here's a quick review of how to use HTTP verbs that you can check out later. Now, this slide is really important because when you're thinking about dealing with HTMX for a particular element, there are really four things to consider. So the first is, what is it that the user does to this element that triggers it to do something? And there are good defaults for all the elements. You see that in the box over on the right. Form elements are triggered when the user submits the form. Input text area and select elements are triggered when their value is changed. And everything else is triggered by default just by clicking it. And that includes the button example that we saw earlier. But we're going to see some examples coming up where we want triggers other than those. And then the second thing is when this element is triggered, what kind of HTTP request do you want to send? Get, put, post, patch, delete. And then when the response comes back, where should it go? And that's what HX target specifies. And you can give that a CSS selector to find the element where you're going to insert the response. And it defaults to inserting into the current element. And then finally, you've specified a target, but where should it go relative to that target? And it turns out there are a lot of options that are summarized on this slide. So here, looking at that snippet of HTML, let's assume that we've set the target to be the UL element. And so in blue, you see all your options for specifying where this HTML coming back ought to be inserted relative to the UL element. So it can be before the beginning of the UL. It could be after the end of the URL. It could be after the beginning of the UL, I mean. So in this case, after begin would mean I'm inserting a new list item at the very beginning of the list. Or it could be before the end. I'm inserting a new list item as the last one. Over on the right, you see that it could be outer HTML, meaning that I'm replacing the entire UL element. And then the default is inner HTML, which means I'm replacing all of the child elements of my target. So in this case, a whole new set of list items. And then down at the bottom, we have two options that don't even use the response HTML coming back. So they're not inserting anything. Delete says, I want to get rid of the content I want to get rid of the target element completely. So delete the URL, the UL element. And then finally, none means I just invoke this endpoint for some side effect. So I'm not going to use the HTML it returns, and I'm not going to update the DOM. I'm going to leave it as is. So lots of options for what to do with what's coming back from these endpoints. The endpoint can return some HTML, but actually there are three ways that it can affect the page as it stands now. So the most common thing is that you're returning a single element that might have elements nested inside it, and that's going to be placed relative to the target element. And so if we think about a to-do application, if I type in text for a brand new to-do and I add it, well, what do I expect to happen? Well, I want to add a new row to that list at the bottom, and the row, of course, contains a checkbox and the text and the trash can icon. But I'm returning that row element. So that's going to get placed relative to the target, which would be that list of to-dos. But I also could return any number of elements that are placed out of band. And out of band here means that it's not relative to the target, it's somewhere else on the page. And the most common way to specify that is just with an ID of an element that's going to be replaced. And so in this case, when I add a brand new to do, I need to update that bit of text that says one of two remaining. In fact, it's going to say two of three remaining because I just added a new one. Now I have two things that I haven't done yet. And so how do I add a new row to my to-do list and also update that status line at the top? Well, the answer is that the status line can be one of those out of band elements. Okay. And then finally, I have the option to trigger events back in the browser. So in that paragraph element you see there, the HX trigger says that I need to listen for the event status change. And where's it coming from? Well, that's an interesting question because there are actually three things that can happen in this to-do application that would cause me to need to update that status. So one is adding a new to-do that we discussed. Another one is deleting a to-do. If I hit one of those trash can buttons, I need to update the status line. And finally, if I click one of those checkboxes and change the state from done to not done or vice versa, I also need to update the status. And so all of those endpoints are going to trigger a status change event. And so the part there that says from body, well, that's just taking advantage of the fact that regardless of where I trigger the events, the checkbox, the trash can, adding a new to-do and that input, all of these events are going to bubble up and eventually they're going to make it to the body of this document. And so I'm saying there, I want to listen on the body element for the status change event. And when I get that, what do I want to do? Well, I want to trigger that HX get. I want to send a request to /to-do/status, and it's going to update the content of that paragraph element, which is where I'm displaying the one of two remaining. So lots of options for how an endpoint can get the UI to update. All right, so we talked about out-of-band swaps. So I'm going to skip past this, and I'm going to try to get to some good examples. So input validation. So as you're looking through these examples, think about how much code you would write with some other framework to achieve the same thing. So here, I'm assuming that this input element over on the left is not inside a form. It's just a raw input element. And I'm saying what triggers this is if I get a key up event and the value that is typed into the input has changed and it hasn't changed again in the last 200 milliseconds. If that's the case, then I want to send a GET request to /email-validate. And with the value that comes back, I want to insert it into the element with an ID of email error. And so all this endpoint is doing is trying to make sure that the email address that you've entered is not one that is already in use. But if it is already in use, I'm going to return the text email in use, and it will display that as you see in the lower right there where it says email in use in red. So the endpoint is just getting the email address that you've typed into the input. It comes in as a query parameter, and then I'm checking to see if it's valid. Well, That logic isn't shown here, but it could be doing a database query or checking against some list to see if it's already there. And then I'm returning some text. And so I'm saying that if it's valid, meaning it's not already in use, I'll return an empty string. Otherwise, I return email in use. So notice how easy this was to set this up so that I can be validating the email on the server and then displaying an error message if there's an issue. Lazy loading is another good example. Displaying the table that you see on the right might be a time-consuming process. And if this is on a web page that is large, and when the user first visits the page, this is scrolled off the bottom of the page, I don't want to take the time to get the data for this table and render it into the DOM if it's not even going to be visible to the user. So what I could do is have the div that you see over on the left that says what triggers it is when it becomes revealed in the browser. So when the page first loads, it won't send a GET request to /users. It's going to wait until you scroll down to that point. And then it will send the request. But in addition, HX indicator says it should display that image down below because it has a matching CSS class. And so it's going to show a spinner while it's loading that data. And as soon as the GET request returns, then I'm going to fill in the div with HTML coming back, which will be that table. It's going to go inside that div, and then the spinner will automatically be hidden for me. So once again, very little code to do something kind of fancy. Active search is another good example. And I'm going to switch over to my browser and show you this in action. And so if I type here just the letter A, I get all the names that are known on the server that have A in them. And I'll type an R and it filters it down further. Yeah, so you get the idea. And the way that this is working is that, again, I have an input, but this case, I'm assuming that it's inside a form. It has the same trigger. If the user has given us a key up event and they've changed what is in that name input and they haven't changed it in the last 200 milliseconds, well, then I'll send a post request to the search endpoint. And when the data comes back, I'm going to display the result in the element with an ID of matches. In this case, it's a UL element. And you see in the code over on the right that it's actually returning a bunch of list items. Now, in case you're not familiar with JSX, down near the bottom there, you see all of those angle brackets. Well, that's called a fragment in JSX. And it's a way that you can return multiple elements, and then you just wrap them in a fragment so it kind of treats it as one element coming back. But all that endpoint is doing is getting the name that you've typed in so far. And if you haven't typed anything, I'll just return an empty string. But otherwise, I change that name that you've typed to lowercase, and I check to see if it matches any of the other names. And I get all the matches, and then I return a list item for all of them. So one more example where we write very little code to do something kind of fancy. And then the last example I want to show is an infinite scroll. And so I need to flip over to where the server is running. You're not seeing my terminal here, but I'm switching what is running on port 3000. And here, down in the network tab, you see I had a request sent for Pokemon rows with a query parameter of page 1. And let me change my zoom a bit here and move this down. And if I scroll through here, you see that at some point I got another request for page 2. And I keep scrolling and I get a request for page 3, and this just keeps going. So that's an infinite scroll. And so going back to the code, I've got this table that says, well, what triggers me? What triggers me is when you load this page. And as soon as that happens, I'm going to make a request for page 1. I have the spinner, but you never saw the spinner when I demoed it because these requests are just so fast, it didn't need to show that. And so this is going to go before the end of the table, the first page. And so I have this hard-coded first row with the headings, and then I get my first page automatically. So if you look over on the right, here's my endpoint for getting the Pokemon rows. And a lot of this building up of the URL is specific to this open source endpoint or free endpoint that I can hit for getting this Pokemon data. And notice that I have to specify an offset. So the offset for the first page is 0, And then the limit is how many do you want back? And then I send the request, I get back my list, and then I'm going to iterate over that list. And I need to do something special for the last row, because when it's the last one, when that comes into view, it needs to automatically send a request for the next page. And that's what you see right here. I'm checking to see, is this the last row? And if it is, I need all these extra HTMX attributes, including this one that ask for the next page. And so I return that row. So the first set of rows coming back don't have those extra attributes. That's this empty curly braces here, but the last one will, so it'll automatically load again. So I'm running short on time, but I just want to point out that there are many other features in HTMX for you to learn about. And there's another library that you ought to look into for client-side handling of data and interacting with the user. This is important because you certainly don't want it to be the case that anytime you need to change the UI, you're always going to send an HTTP request. That could be too slow. So Alpine is a great library to use in conjunction with HTMX to handle those pieces where you don't need to make a trip to the server. I've got all the code for that to-do app at the URL you see here in a GitHub repository, so check that one out. This one even persists the to-dos into a SQLite database. Got a bunch of resources listed here, including a link to my book. And finally, as a wrap up, HTMX gives us a new way to implement web applications that has a whole lot of benefits. The HTML is more expressive. The code you write will be easier to understand, and you'll write less code. State management is much simpler. You can implement using any programming language you like. Faster app startup and faster client and server interaction. So a lot of good things to get from HTMX. And I think I'm just about out of time, but if anyone has questions, I'd be glad to take them.